They should be at the front.
Oh.
All right, so we're going to look at rotational symmetry today. Yesterday we looked at line symmetry. A review of line symmetry. You had horizontal lines, vertical lines, and oblique lines. Remember, oblique were diagonal lines of symmetry. Things that you're going to be asked about line symmetry, you're going to be asked, given a shape. So let's take this shape that we have right here. Does it have line symmetry? Yes. Can you see that there would be a line of symmetry right like that? Is that the only, and across? And through there?
Oh yeah.
And through there?
Yeah.
Whoa. And through here?
Yeah.
And through here?
Yep. Yeah.
It's 8.
And there would be 8 of them?
Yes.
1, 2, 3, 4, 5, 6 of them. So you're going to have to say how many lines of symmetry there are. Now we're going to look at rotational symmetry. Symmetry where you rotate.
That was easy.
All right, so a shape has rotational symmetry when it coincides with itself after rotation less than 360. So here's our shape. I'm going to draw another one right here. If I take this shape and I rotate it, can you see that it matches up?
Yes.
And it matches up the same again here, and it matches up the same there, and it matches up the same there,
No.
and the same there. And now it's back to where we began. Okay? So for rotational symmetry, we have two things that we're going to look at. We're going to look at how many times we can turn it and have it match up with what it was originally. So for this one, can you see I have a point back at the top there? 1, 2, 3, 4, 5, and it's 6 till it gets back. So this one, we're going to say has an order of 6. No. You'll be fine. Here. Ape. Oh. If you have a highlighter or if you want to underline the important things here, right? The number of times a shape coincides with itself is called the order of rotation.
It's already like highlighted for us though.
Kind of bolded, eh?
Yeah,
And the well, maybe you want to do the whole definition. Number of times shape coincides with itself is the order, and the amount of degrees it takes for the figure to coincide for the first time is called the angle of rotation.
takes away the point of highlighting anything.
It's just showing you that this is important. And here is the formula
No, wait.
for the
Highlighting everything that's
angle.
the purpose of highlighting stuff.
I'm not highlighting everything. I didn't highlight anything in the last one.
That one sentence. Sorry, that one sentence.
Okay?
is not important.
So now let's go back to this picture that we had here. For this shape,
60.
we would say that the order is 6, and the angle
60 degrees.
of rotation, if we use the formula says 360 divided by the order, the angle of rotation is 60 degrees.
And 90 degrees is how much Joe's ankles bend. Oh, good one, bud.
So, we say that a shape that takes all 360, to get back does not have rotational symmetry. So we say it can't have a rotational symmetry of 1. We start with a rotational symmetry of 2, and then here are all the angles of rotation. Should add the word rotation in here. Maybe add the word rotation. And since the object we looked at had an order of rotation of 6, we would say that the angle of rotation would be 60 degrees.
What angle? It's really hard to
Okay?
on this one.
I'm gonna make it this.
No, okay.
Do you have to write this down?
No, this is on your next page. Can you see that the letter S has an order of 2? Because if you rotate it 180 degrees, it will match up perfectly to what it was before.
Do it.
You want to watch it?
That'd be pretty-
Okay. So you want to see it. Here, we'll take a
What time?
picture of it.
Step there.
So we take the letter S. We rotate it 180, and it is still a letter S.
It's not exactly.
Well, I don't know. Looks pretty good.
No.
Yeah, the bottom's always bigger.
So you're saying that this S is a little bit off? Maybe.
Draw a normal S, like just like if you're drawing like if you're writing like
Trace it out.
that S. No, Mister.
Just wait. I want to try something. Okay, I didn't do the best job of tracing, but if we,
See?
yeah, it's a little bit off, eh? But it's pretty close.
Because that's like a whole centimeter. If you like draw a normal S, like if you're writing Sarah or like then it like won't be the same.
Okay, so you've got 6 examples here. I want you to say the order and the angle of rotation.
Okay, wait, I don't know. Okay, wait. You can do 90, 180, and then you can do like another one.
Did you get an order of 2? And an angle of 180 degrees.
That's what I got.
What does order mean?
The order is how many times you can turn it before it matches up. So if I turn it halfway, it matches up perfectly again, and then I turn it again and it's back to where it started. It took 2 times that in turning it all the way around, 2 times that it matched up at the very end and halfway through. This one, the order is 4.
Yeah, I was kind of it's hard.
And the angle,
Can you like show us? Like, can you turn it?
I can turn it. So if I trace this out,
How do you get 90? Like, how do you get it?
I win.
I know, but like, when you turn it, yeah,
Okay.
it's 4 times.
and
I think when we were starting.
so if I turn it here,
Yeah.
matches up once,
Okay, because I thought you were
twice,
That's
3 times,
Oh,
4
that
times.
was like what I thought it was when you turn it, it would be like an X, and then now it equals 1.
Yeah, it has to match up with the original shape. So this doesn't count until here. Matches up once. Doesn't count until 2,
Okay, I get it.
3, 4.
I win.
So that's why the order
I wrote
is
that
4.
down. I wrote exactly that.
All right, I'll give you some time on these 2.
You kind of already gave us the
I gave you the answer for D. So should we just do these ones quick together?
well, like, well, for C,
We did this one already. Order was 6, and the angle
60.
was 60 degrees.
Wait, but that yin and yang thing, if you flip it
Yeah.
like the opposite way, then the white's gonna be on one side. So can't you only do it once?
Well, we'll see. That's a good point. So let's take this here and shade this part in.
But it won't be. Yeah, but it won't be the same because.
So if we take it and you go halfway around, the shading doesn't match up, right? It only matches up when it's back. So the order is technically 1. The angle is 360, and we would say does not have rotational symmetry. It kind of has rotational symmetry if you ignore the black and the white.
Yeah.
Like if you just,
Then you can do one either.
but otherwise, because of the shading, it doesn't.
I feel good now. I will accept you. I don't like this, so I'm not gonna beat you on it.
Did you get an order of 5?
Yes.
Awesome. Did you get an angle?
It is 720.
72.
72. 70.
72. And this one has none.
720 as well.
That one you can't rotate to match up. Okay? So, you know how I figured it out on the smart board by drawing over top? And you can't bring a smart board into your exam. 1, 2, 3, 4, 5. Okay. What? Well, it might be just the thing that's off. What you can do on a, if you wanted to do something similar to that on a test, you could take a piece of paper and put it over top of the shape and trace it out and then turn the shape. But one of the things you'd have to find is where the center of the rotation would be so that it would work.
What was the last one like?
So wait, how did you find 72? No, that's like...
There's a formula. The formula says that the angle is always equal to 360, and 360 is how many degrees all the way around, divided by your order. And if you type that into your calculator, you'll get 72.
Yes, lower and lower, okay? Oh, so it'd be 360 divided by orange?
Okay, everybody ready to go? So we're now going to rotate around a certain point. Around a vertex. We're going to rotate this shape 90 degrees clockwise. First of all, clockwise means how the clock is going, which is around this way. If you went 90 degrees, you would start here and go a quarter of the way.
That's like not like it doesn't look like.
So, what's going to happen? I'm going to start with this green line from C to B. If I take that and rotate it 90 degrees clockwise, can you see that this point B would come down over to here? 1, 2, 3, 4.
I can see it when you do it.
Okay?
That doesn't look right. Yeah.
It looks a little bit longer, eh?
See, it looks way like the one that you just drew looks way too long.
It looks too long. Sometimes what happens with the resolution of the projector and what's actually on the computer doesn't match up. When you draw it on yours, does it match up?
Yeah.
Yeah? Now, this line here, when it gets rotated 90 degrees, is going to end up being over here. And this line here is going to end up being right there. Now, when we label our new shape, what we do is we label the new points. This was B. We label it with a B with a little dash because that's the new B. Where did A go? A went to this little point, and C stayed the same, so you can label it with a C with a little dash as well. Again, what could you do on your test? You could trace it out, put your pen right on C, and then turn your page 90 degrees to see what it would do.
You're just gonna see us going like this the whole test.
No, your test tomorrow is on fractions. When you get a test on this.
Why aren't you doing that with us? Why would you tell us that then?
That's why.
Okay.
Still fun.
Yep.
When we're done with this one, can I get a drink of water?
Yep. We're going to take this same shape. Now we're going to rotate this one over the vertex B. 180 degrees counterclockwise. So that's going around this way 180 degrees. Draw your shape. I'll put the answer up in a second, and you can check if you were able to get it right.
I probably just did this one. Yeah, but now we're going counterclockwise.
If you took the blue line from B to C and rotated it counterclockwise, it would end up there, and C with a little dash would end that way. If you took this line and rotated it 180 degrees, it would end right here, and this would be A prime, and finally this line rotated 180 degrees would end right there. 180 degrees counterclockwise. So this is the vertex. Right now. Okay. So we've got that line right there. We are going 120 degrees. It doesn't say, let's go. Generally in mathematics, if they don't say which way they're going for an angle of 120 degrees, they're always assuming that you're going counterclockwise.
Why do they assume that?
It's just the way that angles are generally measured in math. So we've got the angle there. We've got F to G that I've drawn. We want to draw it 120 degrees. Every turn, every triangle here, this would be 60 degrees. Then this would be 120 degrees if you would go two triangles. So this line, which is 1, 2, 3 long, here is turning once, and 1, 2, 3 long. That's turned it 120 degrees.
I thought it was about, is that really about Fahrenheit? It's about Fahrenheit and Celsius.
We just did that test.
Oh yeah.
This one right here
In this class.
goes
We had 3.
rotated once.
That's a lot. We did not get that many tests in middle school.
Welcome to high school, not elementary. Okay.
Not in
Would end up going right there when you rotate it 120 degrees.
I have a question.
This line right here, oops, I'll use a different color. Will end up going right there. And this line right here will end up being right there. Now, on the video, on the graph paper here, it doesn't show up perfectly because it's not quite lined up, but that is how you would do it.
How many subscribers do you have?
So if we're rotating clockwise about F, let's say, here's F, let's say you take this line. Clockwise, of course, goes around this way. You want to do 180. Where's this line going to end up? It's going to end up straight down there.
So you can start out like at any letter?
You can, well, it says rotate about F, so we knew it had to, so it makes sense to start off with the things that are touching F. So if I take this line and rotate it 180, it would go down and then right across, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7. It'll go straight out to there. Then this one, oh, do that in red. We'll go down to there. And finally, now it says shade your final answer, so use favorite color. I'm going to color this in and shade it. Ooh, so pretty. If we were labeling this, this is where E went, this is where G went, this is where H went, and F stayed in the same place because that's where you rotated it about.
Keep this
Okay.
Two more.
So let's see how you did. So we need to rotate this 270 counterclockwise, which would be the same as rotating it 90 degrees clockwise. So you could do it either way. If you rotated this 270 counterclockwise, you would go up, over, and then down. This is 1, 2, 3, 4, 5 long, so I count 1, 2, 3, 4, 5 down, and that's where I would go. If I take this next point right here, and I rotate that 270, it's going to end up right there. Oh, sorry, actually right there. Counterclockwise, 1, 2, 3, 4. It'll end right like that. 2, 3, 4, 5. And we would label that point then this F to G has a length of 3. So you go 1, 2, 3 down to there, and that's where G prime would be. And finally, G to I would end up being right there. If you wanted to shade your final one, pick a nice color, shade it in.
What page is this on?
And then your homework is listed at the bottom of the page.